This is the second part of Lecture 2 on the mathematical model. We know that when we have congested traffic, the distribution of spacing between cars is better represented by a normal probability density function curve. We're going to analyze functions that are not exactly the normal PDF. We're going to represent some similar functions for you to understand the behavior of the normal probability density function. We have a complete description and analysis of the normal PDF along with other distributions plus the cumulative density function of these probabilities, which will be presented in the Monte Carlo section of this course, which is the last lecture. I started the project already with most parts done. I already have imported the libraries. I enter here the constants we need, and I created these three vectors here. And peeling space from -4 to 9, I create the function, which is an exponential function equal to basically 1 divided by x of minus x squared. So it's 1 over, so this one is not. This is the function we're going to draw, and as you can see, it has a very similar look to a normal probability density function. We will add a little more elements that will make it even closer to a probability density function. So we'll create another vector. Let me call this vector y2 equals np dot minus x minus a, which is squared. And I'm going to draw this. It'll be similar to this one. Call this is the y2. This will be like R for red, B for blue. And this will be minus A. As I describe here, A is the mean. So we have that in the probability density function. What does it do to our exponential functions? And here you can see. Now it is centered at the mean. I will draw a central line here. And you will see it will be similar to this one. What I'll do is on the V1, I'll call a V2. Call this V2. Instead of times 0, it will be the mean, the mu. And we're going to plot this as well. We'll also leave it as red, a red line. This one, V2. This will be Y2. Make sure you understand in the example what we are doing here, because your assignment will be to make changes to this. If you understand what's going on, it will be halfway there. This is it for today. Look carefully that this is when the mean is at 0, it is centered here. This is symmetrical. This is pretty much very close to what you need to know about the probability density function. That's a Gaussian, a bell curve, or normal PDF. Thank you very much. That's it for today.